everybody. So the first time I went through this problem, I described how to use the method of joints to solve for every single joint in the entire truss. But now let's focus on specifically these members. So BD over here, CD, and CE. Okay, so if we use the method of joints, you don't need to do this, but one optional starting point is you can take the free body diagram of the entire structure. There you go. Okay, and then if I pick coordinates, there's a pin at A, which I will decompose into X and Y components. There's a roller over here at G, and then there's a 6 kilonewton load right over here. Okay, so the free body diagram of this whole structure is an optional starting point. You don't need to do, but let's go for it. Right, so AX minus G, Y direction, AY minus that load, some torque about anywhere you want. So a clever choice would be either here or here, because then if we sum torque about here, we get rid of this unknown. If we sum torque about here, we'll get rid of here, we'll get rid of this unknown. This is already known. If we sum torque about here, we get rid of two unknowns. So I think that's the most clever. So I'm going to sum torque about point A. Okay, so see this line of action for G, and then this is the lever arm, which is 600 millimeters. So I'll just call that 0.6 meters times G. And then see this line of action from here to here. The lever arm is 800 millimeters. And that's going, actually, this is positive Z, right? So this torque is going in the negative Z direction. Negative 800 millimeters times 6 kilonewtons. Okay, and then let me point out the unknowns. Okay, so see, three equations, three unknowns. AY is 6 kilonewtons. Solve for G, right? G is 4.8 over 0.6. Okay. Okay, so let's see, that should be 8 kilonewtons. AY is 6 kilonewtons, and then AX equals G, which is 8 kilonewtons. Okay, so we got all three reactions. All right, so now let's go method of joints. So let's think about it. So for joint A, there are these two members here, so there will be two unknowns, and I already know the two reactions at the pin support. So starting at joint A, it looks like this, and then the reactions, AY at the pin support, and this is member AC, member AB. So I'm drawing my axial forces in tension, and if I call this angle theta, what is angle theta? Opposite over adjacent. So that's 300 over 400. Okay, just punch that in the calculator. Now we know the angle. So here's joint A. Some forces X, AX plus TAB plus TAC cosine theta. Y direction, AY plus TAC sine theta. And the unknowns are AC and AB. Right, so look at that. Two equations, two unknowns. Solve this one first. So now you know TAC. And then take that number, plug it in over here, solve for TAB. Okay, so now we know all four of these. Now where should we go next? if we go to joint C, this is known, but we would have 3 unknowns. So, but if we go to joint B, this is known, these 2 are unknown. So there will be 2 unknowns. So let's go to joint B. Okay, joint B looks like this, right? So A, B, B, D, B, C. Okay, so we can write 2 equations. So in the x direction, minus TAB plus TBD. In the y direction, TBC. And that's it. Okay, so let me point out the unknowns. So BC, BD. We already know this from right here. Okay, so if you look at it, TBC is 0, TBD is exactly equal to TAB. So now we know all 3 of these. Okay, now if we go to joint C looks like this. Let's see, A, B, D, E. A, B, D, and E. D, E. Okay, and we already know these 2, right? Because we solved it over here, this one. And then BC is actually 0. Okay, so then, and then again, this angle right here is arctangent of 300 over 400. So it's the same angle as this one. Okay, so also over here, same angle. Okay, so x direction minus TAC cosine theta plus TCD cosine theta plus TCE. Y direction minus TAC sine theta minus TBC minus TCD sine theta. And point out the unknowns, CE and CD. Okay, so 2 equations, 2 unknowns. Which one do you want to solve first? This one, solve that for CD, take that value, plug it in over here, then you got CE. And that's all we were looking for, right? BD, CD, BD, where is that? Oh, we solved it already over here. CD, just solved it over here, and CE, got it. Okay, and then that's it for this problem. Okay, hopefully that was helpful. Let me know if you have follow-up questions here. I'll see you on the next video.